Hello everyone, welcome back to Slide Science. Today, we are going to learn an amazing topic from physics called the ray model of light. In this video, we will understand how light travels, how mirrors work, how images are formed, and what reflection means. Let us start with the ray model of light. The ray model of light explains that light travels in straight lines. These straight paths are called rays. Rays are usually shown as straight lines with arrows. The arrows show the direction in which the light travels. A very common example of a ray is the beam of light from a laser pointer. If you use a laser in a dark room, you can notice that the light travels in a straight path. Light continues to move in a straight line until it hits an object like a wall, mirror, or glass. Now the question is, what happens when light hits an object? When light rays encounter an object, three things can happen. The light can be reflected, absorbed, or transmitted. First, reflection. Reflection occurs when light bounces off a surface. Mirrors are the best example of reflection. When light falls on a mirror, it bounces back. This reflected light enters our eyes and allows us to see images. Second, absorption. Absorption happens when a material takes in light energy. Most of the absorbed light changes into heat energy. For example, black clothes absorb more sunlight, which is why they become hotter in summer. Third, transmission. Transmission happens when light passes through a transparent material like glass or water. Transparent materials allow light to move through them, which is why we can see through windows and clean water. Now let us understand ray diagrams. A ray diagram is a drawing that shows the path taken by light rays. It helps us understand how light travels from a source to an observer or a screen. Ray diagrams are very useful for studying mirrors, lenses, and cameras. Now let us move to mirrors and reflection. Mirrors work on the principle of reflection. When light rays from an object strike the surface of a plane mirror, the rays bounce back from the mirror surface. The reflected rays travel in a different direction, but they follow an important rule called the law of reflection. Before learning the law of reflection, let us understand some important terms. The incoming light ray that strikes the mirror is called the incident ray. The ray that bounces back from the mirror is called the reflected ray. At the point where the incident ray touches the mirror, we draw an imaginary line perpendicular to the mirror surface. This line is called the normal. The angle between the incident ray and the normal is called the angle of incidence, represented by the letter I. The angle between the reflected ray and the normal is called the angle of reflection, represented by the letter R. The law of reflection states that this means the angle of incidence is always equal to the angle of reflection. If a light ray strikes the mirror at 40 degrees, it will reflect back at 40 degrees. Now let us learn how to draw a ray diagram for a plane mirror. First, draw the object in the plane mirror. Then, draw an incident ray traveling from the object towards the mirror. Next, draw the normal line at the point where the ray touches the mirror. After that, draw the reflected ray in such a way that it follows the law of reflection. Now, draw another incident ray from the same point on the object and also draw its reflected ray. Extend both reflected rays backward behind the mirror using dashed lines. These dashed lines are not real rays. They only show where the rays appear to come from. The point where the extended rays meet behind the mirror is the position of the image. Now let us understand the characteristics of the image formed by a plane mirror. The image formed by a plane mirror is upright. This means the image is not upside down. It is in the same orientation as the object. The image is also the same size as the object. If the object is tall, the image will also appear equally tall. The image is laterally inverted. This means the left side of the object appears as the right side of the image, and the right side appears as the left side. This is why words look reversed in a mirror. Another important characteristic is that the image forms at the same distance behind the mirror as the object is in front of the mirror. If you stand 1 meter away from a mirror, your image appears 1 meter behind the mirror. And that is the complete explanation of reflection and images formed by plane mirrors.
A pinhole camera is a very simple device that forms images without using a lens. It works on the principle that light travels in straight lines. A pinhole camera has a tiny hole on one side and a screen on the opposite side. Light rays from the object pass through the tiny hole and form an image on the screen. The interesting thing is that the image formed by a pinhole camera is upside down, or inverted. Why does this happen? The rays from the top part of the object travel downward after passing through the pinhole, while the rays from the bottom part travel upward. Since the rays cross each other at the pinhole, the image appears inverted on the screen. The image formed by a pinhole camera is also smaller than the object. The size of the image changes depending on the distance between the object and the pinhole. If the object is closer to the pinhole, a larger image is formed. If the object is farther from the pinhole, a smaller image is formed. Now think about this. What happens if we make the pinhole larger? A larger pinhole allows more light to enter the camera, making the image brighter. However, the image becomes blurry or fuzzy because light from one point on the object spreads to multiple points on the screen. So a very small pinhole produces a sharper image. Now let us quickly review everything we learned in this chapter. The ray model of light explains that light travels in straight lines called rays. When light hits an object, it can be reflected, absorbed, or transmitted. Reflection is the bouncing back of light from a surface. Absorption happens when light energy is taken in and converted into heat. Transmission happens when light passes through transparent materials. A ray diagram shows the path of light rays. Plane mirrors follow the law of reflection, where the angle of incidence equals the angle of reflection. The image formed by a plane mirror is upright behind the mirror. A pinhole camera forms an inverted image because light rays travel in straight lines and cross at the pinhole. And that is the complete explanation of the ray model of light in the pinhole camera. If you enjoyed this video and understood the topic clearly, make sure to like, share, and subscribe to Slide Science for more amazing science videos. See you in the next video.